Okay, welcome everybody to Electric Education Center, educational session number 9, commercial swimming pools. Last week I talked about residential swimming pools and the importance of inspections and all that. So this week I want to concentrate on commercial pools. So this session is totally covered by NEC Article 680. And how it relates to the electrician is he's the installer. How does it relate to the inspector? He's the one that's looking to make sure that everything was installed the correct way and is code compliant. So this week I'll discuss the swimming pools like those found in, for example, secondary schools, high schools, colleges, community pools, retirement complexes, hotels and motels. Those are the commercial swimming pools. You know, as far as inspections are concerned, the rules are all over the place. Each of the states in the United States have their own idea of what should be inspected, how often, and by whom. For example, Pennsylvania requires a triennial pool bonding inspection by a third-party inspection agency. New Jersey requires a 5-year bonding inspection, and they allow it to be performed by an inspection agency or a licensed electrical contractor. In addition, there's an annual general inspection required to be performed by the local subcode official. In Maryland, you would follow the Code of Maryland regulations for public swimming pools. Plus, the pool has to meet the requirements of the individual counties if there are any requirements special. Like, for example, Queen Anne's County has some special rules to follow. In New Mexico, check with the Environment Department pool program. And in Iowa, there is an annual inspection required. So as you can see, there's a wide variation of requirements and a wide variation in just who is allowed or who is deemed qualified to perform these inspections. So you got to check with your local municipality and see what the rules are. In your world, you should always promote inspections to your customer list. Some people may not actually know that there's state requirements for these pool inspections and pool safety. Most states, I would imagine, have inspectors who go around to make sure that the required inspections have been completed and any deficiencies rectified before the pool is allowed to be open for the season. Keep in mind, there is no reason not to do an inspection every year. You know, you don't have to wait around, offer it to your customers. 3-year periods and 5-year periods are too long, in my opinion. Contractors should offer it to their customer list, and inspectors should offer it to their contractor list. Get these inspections going. So let's start the inspection with the required GFI protection. This GFI protection is mandatory for indoor. The words in the code are all single phase receptacles rated 125 volts through 250 volts, less than 150 volts to ground, and 50 amps or less, as well as all receptacles supplied by 3-phase 100 amps or less and still 150 volts or less to ground per 210.8b as in Bravo. Now the outdoor outlets are required to be GFI protected per 210.8 F as in Francis. This is new to the 2020 NEC. And notice that it says all outdoor outlets. So that would include receptacles and any point where electricity is taken off the system, like at disconnects for equipment, for example. So new in the 2020 NEC, all outdoor outlets per 210.8 F. Now note that the 150 volts or less to ground means that it includes the 120/240 volt systems and the 120/208 volt systems, but it does not include the 277/480 voltage equipment, since one leg to ground is higher than 150 volts. So that's the voltages it applies to. GFI protection for motors includes all outlets supplying all pool motors on branch circuits rated 150 volts or less to ground and 60 amps or less single or three-phase per 680.21c. So you can see that there's a little bit of difference here between the 680 and the NEC Article 210 as far as what the amperage levels are. So make sure also that in that 680 you check out the new 680.21d as in Delta. This new section requires that if a pool pump motor is replaced during a regular maintenance program or during pool repair, it must now be provided with GFCI protection. So I know what you're going to say. You're going to say, well, Rich, the maintenance program, at the end of every season, we take out this pool pump motor, and then in springtime, we put it back in and hook up the bonding conductor. Are you saying that we have to provide GFCI protection at that point? And I would say yes. Regular part of a regular maintenance program, I would say yes. There's no reason that any of these motors should not be GFCI protected. Don't be looking for excuses not to do it. As with most rules in the NEC, they're there because of a body count. Somebody's been hurt. So due to the inconsistencies in the past 4 NEC issues, there have been some motors that did not require GFCI protection when the motor was originally installed. So what happened? Well, there was an electrocution after a motor was replaced, and again, not put on GFCI protection because it was not on GFCI protection originally. And then the motor was miswired, and then the pool water was electrified, and somebody died. And so that's why now, fast forward to the 2020, but this rule is already also in the 2017, that all pool pump motors have to be GFCI protected in that voltage range I mentioned earlier. When you test the GFCI devices, okay, make sure that you use the test and reset on the receptacles or on the circuit breakers. That's the way the manufacturer wants you to check them, and that's the way you're supposed to do it. And 110.3b in the National Electrical Code tells you that you have to follow the manufacturer's instructions. And that's what you will do if you want to keep yourself out of trouble and if you want to keep your electrical installations safe for the general public. Bonding and equipment grounding is a requirement of 680.6, section 680.6. So the bonding is explained in section 680.26. And basically bonding means that you're going to connect together all normally non-current carrying metal parts together using at least an 8-gauge solid copper conductor. So this would include all metal located within 5 feet of the water's edge and include, but not limited to, water fountains, underwater luminaires, pool pump motor frames, diving board stands, door and window frames, fencing, pool water heaters, metal ladders and handrails, handicapped lifts, the conductive pool shells, the perimeter surfaces within 3 feet of the pool. That means the perimeter surface, what you're walking on, within 3 feet of the pool has to be bonded. And metallic sheath cables or raceways have to be bonded. And the pool water itself has to be bonded with metal that's at least 9 square inches, at least 3 inches by 3 inches exposed to the water. Now that could be accomplished by a rail or a metallic ladder that is bonded, or the trim around a luminaire that is bonded. There's different ways to do it. There's also, look online, there's also inserts into the water return that you would put like a plug into the PVC, and that exposes at least 9 square inches to the water. So we're supposed to be bonding the water itself. I recommend to check the presence and condition of this bonding conductor by using a meter that drives current. You know, I see a lot of guys, and you'll see them on the internet, you'll see guys saying, oh, this is how you check bonding. You know, you get your multimeter and you get some long leads, and then you see if it reads 0 ohms. That's not how you do it. That bonding conductor has to be able to carry enough current to trip out a circuit breaker, for example. And you're not going to prove that it could do that by driving the current from a little battery in your meter that tells you there's 0 ohms from point to point. That doesn't prove that it can handle enough current to trip the breaker. So like I said, I recommend that you use a tester, a pool tester that drives current. If you want further information on this, testing it this way, just email me, richvanwert@gmail.com, richvanwert@gmail.com. All right, so that's a little bit about the bonding. And these bonding conductors, they have to be connected according to code also. And those rules are in section 250.8 in the grounding article. And go to section 250.8 to see what's the correct way to hook up these bonding conductors. Now let's discuss grounding. Different animal now. The grounding requirement is for all luminaires, receptacles, pool pump motors, any other motors there are because of the pool, junction boxes, that's what you would call a deck box, GFI receptacles, pool circuit breaker panel boards, and whatever else might be involved, but it's not listed here. They all have to have that equipment grounding conductor. It's going to be at least a minimum 12 gauge insulated copper conductor. So normally your equipment grounding conductor is sized as usual with table 250.122. And the size of the wire depends on the size of the overcurrent device. In other words, the size of the circuit breaker. While you're in that pool electric room doing your inspection, pay close attention to another important item covered in section 680.12. This is a section that requires that the room that houses the pool electrical equipment has to have drainage to prevent water accumulation during normal operation. Then look around that same room and look at the condition of the pool circuit breaker panel. Is it all corroded and rusted and the paint is flaking off because of the corrosive atmosphere caused by chlorine and other pool chemicals? Is it or did it used to be a NEMA type 1 enclosure? A NEMA type 1 enclosure is not listed. It's not able to be used in a corrosive atmosphere. And that's why these things look so bad. Check out NEC table 110.28 and see what type of equipment enclosures for corrosive atmospheres are allowed. And you'll see that in this situation that I'm talking about, only NEMA type 4X or 6P fit the situation. So the NEMA 4X is an aluminum or stainless steel and corrosion resistant enclosure. That NEMA 6P is also stainless and corrosion resistant, but it's usually a bolted box that's resistant to occasional submersion. You don't need a NEMA 6P in that swimming pool mechanical room. So in the corrosive atmosphere of this pool mechanical room, you're generally going to use a NEMA 4X enclosure for the circuit breaker panel. So when you're performing any kind of pool inspection, be sure to check the following list of items. First of all, check all GFCI devices, both receptacles and breakers that need to be checked out and tested. Hit the test and reset buttons, etc. Some luminaires may need to be on GFCI protection also. How do you know which ones have to be on GFCI? Check the envelope around the pool per an extensive NEC section 680.22b. Check your emergency lighting systems. If it's an individual base unit with a battery included inside of it, you can hit each test button and make sure that these emergency lights work. If it's an emergency lighting circuit with many luminaires on one circuit, on one breaker, and they're up high over the pool or something like that, you should be able to turn off the breaker and the emergency lights go on. Pool bonding conductors, you're also going to check. Those are the 8-gauge solid copper conductors. They can be bigger than 8 gauge, but the code requires minimum 8-gauge solid, no stranded conductors. It also says that it could be insulated or bare. Now, I've heard some inspectors say that they only allow insulated conductors, and if they get that to float, that's fine. But the code book says they could be insulated or bare. Are the drinking fountains on GFCI? Are you serious, Rich? You want me to check to see if the drinking fountains are on GFCI protection? Yes, that's per code. The drinking fountains have to be on GFI protection. Now, they could be direct wired, or if you take the access panel off the front of these drinking fountains, you'll see that they have a cord inside that's plugged into a receptacle right inside the enclosure. That would have to be a GFI type receptacle. It's got to be a readily accessible type of device that we can check and reset every month. How about the retractable bleachers? Check out the motor and the disconnect operation. And again, is that motor on GFCI protection? As you look around, are there any extension cords laying around this pool? You'll see them, and generally there should not be any. Recommend in your written report that the extension cords that you found signal the need for an installation of more receptacles in those locations. And I emphasize in writing. Lastly, what is the condition of the pool circuit breaker panel itself? Is it corroded and the bottom rusted out like I've seen on job sites? I look underneath the panel, the bottom is gone. It's completely gone, it's rusted out. What's the condition of the electric conduit and the fittings? Are there any corrosion problems there? You know, you'll have guys trying to use EMT conduit in a corrosive atmosphere and it's rusted away to nothing. You don't even have a complete raceway there in some places. And then it's got to be written up to replace the conduit. Yes. Is there a clear working space of 3 feet in front of the circuit breaker panel where a guy would have to stand and work for an hour or 2 hours, something like that? Is there, does he have that clear working space that's required by 110.26? I want you to also review the low voltage lighting rules in 680.22B6, 680.22B6. The reason being that there are some low voltage lighting systems that are allowed to be installed within less than 5 feet from the inside walls of the permanently installed pool. Now, the acceptable voltage levels are listed in 680.2 in the definitions section. And they give you 4 different voltage levels. The first one is 15 volts or less RMS, root mean square, in the normal AC sine wave shape. So it's a normal, everyday S-shaped sine wave, 15 volts or less. 21.2 volts peak for non-sinusoidal, and that is nothing more than a generated square wave. Okay, so those generated square waves can't be any higher than 21.2 volts. The third option there is straight up 30 volts, steady DC, 30 volts or less is allowed to be within 5 feet of the water's edge. And then the last voltage there is 12.4 volts peak for interrupted DC level. All right, that's your 4th option. So if you have one of them, then that lighting, like I said, can go within 5 feet of the water's edge. Otherwise, if it's higher than that, it's got to be at least 5 feet away or 10 feet away. Again, read the manufacturer's instructions. So the other thing about the bonding that I wanted to say is, you know, you got to use the right connectors. And this here is a rebar designed clamp. Okay, the rebar is going through this side and our wire is going through this side here. And this is listed for 1/2-inch rebar, and it's good for 8 gauge through 4 gauge conductors. And it'll say right on it, direct burial. It'll say DB, direct burial. Also, this style pipe clamp, okay, this comes with a tag on it. It's a plastic tag that does not disintegrate, and it says suitable for direct burial in earth and concrete. So these two can also be used underground. Now, the problem comes in when guys will use this type of clamp but they'll use the indoor rated. They'll use the zinc clamp, and they don't last long at all. Okay, that is those clamps are made for indoors, not outdoors. So if you can see it here, I have Aerotech poster here, and they give all different connectors here. They also talk about CAD welding. Sometimes on these pools, the engineer might require CAD welding. And but go to Aerotech, look them up online. They have all these excellent connectors that you could use when you're doing your pool bonding. So in closing, there's no need for an electrical emergency around a swimming pool. There's no need for people to get shocked or electrocuted. You should take a first aid class to know what to do in situations, so that you can already think ahead and know what you're going to do if you see somebody involved. I actually had two guys in my class here that the one guy went into the pool to work on a luminaire, an underwater luminaire. Instead of going in and taking it and bringing it up on deck, he went in the pool to work on it, and he was getting shocked. And when you're getting shocked and the electricity is going through your body is paralyzed. You just can't swim. You can't move your arms. So his buddy pulled him out. And so the rest of the guys in the class were having a good laugh about it and everything like that. And then he said, and Rich, you know what? That's not the best of it. He did it again a second time. After almost dying the first time, he did it again the second time, getting shocked like that. Not a good idea, okay, to take a chance in that situation. Yeah, you got to think ahead. You got to have a plan. You got to have a job safety analysis. You got to know how to do these pool inspections the right way. So create your own inspection checklist of what you want to look at and follow, and don't trust your memory as to what has to be checked. Create your own checklist that you keep adding to, and then you'll make sure that you don't miss anything on your pool inspections. Help to keep all the swimmers safe, okay, and feel free to send in your comments to me. Van Wert out.